Okay, so in this particular problem here, we are told we have a normal distribution, and that's key, that it's normal, and that we're told it's normal, and that we're looking for type 2, 5% significance, where this is the mu and the alternative hypothesis, n is 30, which will be important, standard deviation, and then the true value is this. So if we set this up, what I know is that I have some kind of a normal distribution here where we would test that this is 7 and that we're looking for bigger than 7. So somewhere over here where this area is 0.05, we're looking for some value k to define our critical region. Knowing that any position underneath here represents a group of 30. So to find that, if I'm looking for the probability, I know also that x is normal, mean of 7, and the standard deviation is going to be 0.4 over the square root of 30 squared for the variance. So I'm looking for the probability that x is bigger than or equal to k. I want that to be equal. I want that to be equal to 0.05. And so to do that, in my calculator, I'll do inverse normal, and I'll find k will be 7.1201. Okay. Now the reason why I have that is because this value k is 7.12. However, what I know from this problem is that the true value is 7.1. So 7.1 is going to be approximately here. So if I draw a similar normal curve, where here's my 7.1, here's what is believed to be true, and if I take this critical region down, 7.1201, this side here is my probability of a type 2, because it's the probability of failing to reject the null hypothesis. So I fail to reject when my value is on that side of that line. But this is the normal curve I actually consider. So I'm going to look for the probability that y, where y is normal, but 7.1 with the same standard deviation. I want it to be less than or equal to 7.1201, given the mean is 7.1. So when I calculate that probability by normal CDF, I get 7.12.01, and this is, I'm putting my calculator, and I get 0.608. And so this is type 1, type 2 when you have a normal distribution. The premise of this, like on this side or the left side, which side of this critical region you're looking at, is the same whether it's binomial or Poisson, anything, but you have to find the actual probabilities you're looking for based upon the distribution that you're told. So the overall idea of a type 1 and type 2 error is the same whether it's normal or binomial or Poisson, but how you calculate it is different.